Copy into is Snowflake's primary command for efficiently loading large datasets from cloud storage like Amazon S3, Google Cloud Storage, or Azure Blob Storage into Snowflake tables. It supports common file formats such as CSV and Parquet. This method leverages Snowflake's parallel processing capabilities for high-performance data ingestion, making it a cornerstone of Snowflake's data warehousing functionality. In recent years, Snowflake has refined copy into to improve scalability and security. The first major enhancement is intelligent scaling, which dynamically adjusts compute resources based on data volume, reducing load times by up to 40%. Next, support for Z-standard compression in CSV loads minimizes storage costs while maintaining high speed, cutting costs by up to 25%. Schema evolution detection for Parquet allows tables to automatically adapt to changing file structures without manual intervention, eliminating the need for constant schema updates. Finally, the skip file on error option enhances error tolerance by skipping corrupted files during CSV loading, preventing entire load operations from failing. Copy into integrates seamlessly with Snowflake's data governance framework, including row-level security, ensuring encrypted data loading. Native support for AWS IAM roles in S3 stages simplifies authentication. Copy into operates within Snowflake's serverless architecture, eliminating the need for dedicated clusters. Integration with hybrid tables facilitates seamless data lakehouse workflows. These security and integration features ensure copy into provides secure, efficient, and flexible data loading within Snowflake's ecosystem. The copy into process begins with staging files in cloud storage. Files are placed in services like Amazon S3, Azure Blob Storage, or Google Cloud Storage. You can create a stage using the create stage command or reference existing external stages. Here's an example of creating a stage for Azure Blob Storage. The create stage command specifies the URL, credentials, and encryption type for secure access. Next, the copy into statement loads data from staged files into a Snowflake table. It specifies the target table, the source files from the stage, the file format like CSV or Parquet, and any optional transformations. For CSV files, copy into supports various delimiters like commas or tabs. It can skip headers to ignore column names in the first row and perform data type casting to ensure columns are loaded with the correct data types. For Parquet files, copy into handles columnar compression, which stores data efficiently by column rather than row. It also processes the file's metadata, including schema information, to ensure proper loading without manual schema definition. Snowflake leverages parallelism by partitioning large data files into smaller chunks that can be processed simultaneously across multiple virtual warehouses. This multi-cluster architecture ensures efficient bulk loading by distributing the workload. During the loading process, you can apply data transformations and validation functions on the fly. Loads are compute efficient and build per second on virtual warehouses, making them cost-effective for large datasets. To manage costs effectively, start with smaller warehouses for testing and scale up for production loads. Use monitoring tools like query history to track performance and error on column count mismatch to ensure data integrity in CSV files. The future of copy into involves AI-assisted data ingestion. Snowflake's Snowpark ML integration allows copy into to pre-process data for machine learning models directly during load. While copy into is batch-oriented, it's evolving towards semi-real time via event-driven triggers, for example with Apache Kafka connectors, hinting at hybrid batch and streaming modes. Consider a retail company that needs to load daily sales data into Snowflake. The data is stored in Amazon S3 as Parquet files, which are efficient for analytics. Using the copy into command, the company loads these Parquet files into Snowflake tables. The process handles the bulk data efficiently through parallel processing. Parallel processing means multiple parts of the data are loaded simultaneously, resulting in faster query performance for the retail company's analytics. Additionally, copy into supports schema evolution, automatically adapting to changes in the product catalog without manual intervention. This reduces extensive ETL downtime. This example demonstrates how copy into streamlines the data loading process for real-world retail operations, enabling quick access to sales insights. Experts emphasize copy into superiority over traditional ETL tools for cloud-native loads. Statistics show high adoption rates among Snowflake users and significant cost savings compared to competitors. Copy into reduces complexity compared to other tools, while its error handling reduces failed loads, highlighting the value of copy into for bulk data loading into Snowflake.